All right, so as I said, page 344 in the book today, and we are going to talk about exterior angles of triangles. And then tomorrow we'll go more into the inequalities in triangles. Now, there's a theorem on the top of page 345. Exterior angle inequality. And what it says that the measure of an exterior angle of a triangle is greater than the measure of either of its remote interior angles. And we talked about this earlier in the year in regard to finding the measure of an exterior angle. So let's look at this triangle here. In this triangle ABC, we've got 1, 2, 3, 4 angles. We said earlier in the year that an exterior angle is formed by the extension of a side of a triangle and its adjacent side. So if we take side AC and it's extended past point C, which it is here, the adjacent side to side AC, now that we've extended it, is side BC. So BC and AC, with this extension out here, form an exterior angle, angle number 1. Well, the rule about angle number 1 is that the measure of angle 1 is equal to the measure of angle 3 plus the measure of angle 4. Because the measure of an exterior angle of a triangle is equal to the sum of its remote interior angles. And angle 3 and angle 4 are remote interior angles for angle 1. So if angle 1 is equal to the sum of angle 3 and angle 4, then the measure of angle 1 is greater than the measure of angle 3, and the measure of angle 1 is greater than the measure of angle 4. If we have to add 3 to 4 to get the measure of angle 1, then doesn't 1 have to be bigger than both of them individually? Okay. So now I'm going to draw some triangles, because where this gets confusing is if you glance at your book on page 345, in example 1, what they start doing is putting multiple triangles in one diagram. And that's where this rule gets confusing. So for just 1 second, or for just this next example, don't write anything down, just watch. Because if I draw this triangle right here, ABC, isn't this the exterior angle right here? Angle 1, see it? And isn't this and this, angle 3 and angle 4, it's remote interior angles? Everybody see that? All right, well, what happens is the book and on your quiz and on your study guide is they will add like a segment right here, and then they could call this 5, and they could call this 6, and they could call this angle 7. Well, isn't angle 1, nothing has changed about angle 1, has it? It's still an exterior angle to triangle ABC. And it's still greater than angle 3 and angle 4, isn't it? But what they did do was they took angle 7 now, and didn't they make it an exterior angle for, if we call this ABC, does everybody see triangle DCB? We got triangle DCB, and isn't angle 7 an exterior angle there? And isn't it greater than angle 1 and angle 5? You guys see that? Okay. Now, 7 is also an exterior angle for this big triangle here, DBA. I hope you see that. And so doesn't the measure of angle 7 have to be greater than the measure of angle 3? And the measure of angle, isn't 7 this exterior angle? Do you see these two combined right here at vertex B? Angle 5 and angle 4 added together make this angle up, don't they? So angle 7's got to be bigger than angle 3, and it's also got to be bigger than angle 5 and measure of angle 4. Is that making any sense? I hope. All right, so with that said, let's draw that big triangle in example 1, and let's talk our way through that problem so you can get a better feel for what you're going to be doing today. So draw that diagram there the best you can. And then we'll put all these numbered angles in here. Okay, so the directions are to use the exterior angle inequality theorem to list all the angles that satisfy the stated condition. We need less than angle 7. Less than angle 7. So if we identify angle 7, it's right here. It's this exterior angle. It's an exterior angle for two different triangles. Angle 7 is an exterior angle for triangle LKM. Agreed? And it's also an exterior angle for triangle LKJ. So that means that angle 7, we need all the angles less than angle 7. If angle 7 is an exterior angle for triangle LKM, then it's greater than angle 4 and angle 5. Okay? So if 7 is greater than 4 and greater than 5, then if we're listing the angles that are less than 7, one of them is going to be angle 4, and another one is going to be angle 5. Now, since angle 7 is an exterior angle for this small triangle inside and this larger triangle around the outside, LKJ, then this angle right here, this combination of two angles, that's an exterior angle, or I'm sorry, that's a remote interior angle for angle 7 in the big triangle, and so is this angle right here, angle 1. So what else is less than angle 7? We've already got 4, we got 5. What else? Anybody see anything else? Very good. 1 and 2. Angle 1 and angle 2. Angle 1, just because of the rule that it's a remote interior angle to angle 7. And angle 2, because it's part of another remote interior angle to angle 7, but it's combined with angle 4. All right? All right, next question they ask you, measures greater than angle 6. Greater than angle 6. Now, sometimes it may be easier to just redraw if you're getting confused, because there's a lot going on here. Meaning, if I take angle 6 here, and I do this, I'm going to go here, here, and here. This is point L, this is point K, and this is point M. I'm going to label this angle 6. Here's 4, 5, and 3. All right, I eliminated all the clutter around the outside so that we can focus on angle 6. Here's angle 6. Here's angle 6. Do you see now how angle 6 is on the inside of this triangle, MKO? And angle 3 is an exterior angle. So angle 3 is equal to the sum of angle 4 and angle 6. So doesn't 3 have to be greater than 4 and 6? All right, so greater than angle 6. That's just going to be angle 3. All right, let's look at that next drawing on the guided practice. And it could possibly be even a little bit more confusing. So try to get that drawing best you can. So what we're kind of looking at is this, and then we're going to connect something here. So here's P, Q, and R. And then we're going to put kind of this V in here. And now this vertex right here, that's at the part of this V, that's actually a letter S. It's not a 5. And then the angles numbered are 1, 8, 2, 3, and 4. 7, 5, and 6. The first question that gets asked is less than the angle's less than angle 1. So here's angle 1 down here. It's an exterior angle. And it's an exterior angle to triangle PRQ. So since it's an exterior angle to triangle PRQ, like we said earlier, don't angles 5 and 6 make up one of its remote interior angles? And doesn't the combination of angles 3 and 4 make up its other remote interior angles? So since that's the case, then angle 1 has to be greater than 3 and 4. So it's going to be the angles that are less than angle 1. That's going to be angle 3, angle 4. And what are the other ones in relation to angle 1? Very good. Angles 5 and angle 6. Because 5 and 6 make up the other remote interior angle, and the remote interior angles are smaller than their corresponding exterior angle. All right, so then you're asked for greater than 8. Greater than angle 8. So if you're looking for something greater than angle 8, you want to look for an exterior angle that corresponds to angle 8. So angle 8 is an interior angle. It doesn't correspond to angle 1, but it does correspond to angle 2 up here. Yes?
Oh.
All right, good question. She said how? Watch. If we get rid of this clutter, and let me redraw, let me go here, 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 and this. Here's angle 8. Here's angles 5 and 6, right? Here's 5, here's 6, here's 3 and 4, and here's angle 2. So do you see angle 2 on the outside of this triangle? This triangle QRP? Angle 2 is an exterior angle for triangle QRP. Angle 8 is a remote interior angle to angle 2. And what's the other remote interior angle to angle 2? Isn't it the combination of 5 and 6? All right, so in this picture, the only angle greater than angle 8 is going to be angle 2. Are you seeing it any better?
Yeah.
Okay. Exterior angle, an exterior angle is greater than the sum or is equal to the sum of its remote interior angles. Exterior angle is equal to the sum of its remote interior angles, which means it has to be greater than them, whether two angles make up one of the remote interiors or just one. So then we've got another exterior angle, angle 2. The measure of angle 2 is equal to the measure of angle 8 plus the measure of angle 5 and 6 combined. So 2 is greater than 8 and 2 is greater than 5 and 6, which means that 8 is also less than angle 2. Okay? Angle 5 is less than angle 2. Angle 6 is less than angle 2. All right? So I know this can get really confusing at sometimes. And sometimes you just have to draw a smaller version of the triangle and the exterior angle that the question is asking you about in order to eliminate the confusion from the rest of the lines and numbers that they're putting in the problem. So your practice for today is going to be on page 348. Problems 1 through 4. And then 8 through 13.